In applied physics, the concept of controlling self-organized criticality refers to the control of processes by which a self-organized system dissipates energy. The objective of the control is to reduce the probability of occurrence of and size of energy dissipation bursts, often called avalanches, of self-organized systems. Dissipation of energy in a self-organized critical system into a lower energy state can be costly for society, since it depends on avalanches of all sizes, usually following a kind of power law distribution, and large avalanches can be damaging and disruptive. Self-organized criticality control schemes. Several strategies have been proposed to deal with the issue of controlling self-organized criticality. The design of controlled avalanches. Daniel O. K. Guerrero and Roberto F. S. Andrade show that if well-formulated small and medium avalanches are exogenously triggered in the system, the energy of the system is released in a way that large avalanches are rarer. The modification of the degree of interdependence of the network where the avalanche spreads. Charles D. Brummett, Racer M. D'Souza and D. A. Light show that the dynamics of self-organized critical systems on complex networks depend on connectivity of the complex network. They find that while some connectivity is beneficial, too much connectivity gives space for the development of very large cascades and increases the size of capacity of the system. The modification of the deposition process of the self-organized system. Pierre-André Knoll, Charles D. Brummett and Racer M. D'Souza show that it is possible to control the self-organized system by modifying the natural deposition process of the self-organized system, adjusting the place where the avalanche starts, dynamically modifying the local thresholds of cascading failures. In a model of an electric transmission network, Heiko Hoffman and David W. Payton demonstrated that either randomly upgrading lines or upgrading broken lines to a random breakage threshold suppresses self-organized criticality. Apparently, these strategies undermine the self-organization of large critical clusters. Here, a critical cluster is a collection of transmission lines that are near the failure threshold and that collapse entirely if triggered. Applications. There are at least 4 different types of events that may arise in nature or society, where these ideas of control may help us to avoid them. Flood caused by systems of dams and reservoirs or interconnected valleys. Snow avalanches that take place in snow hills. Forest fires in areas susceptible to a lightning bolt or a match lighting. Cascades of load shedding that take place in power grids.